An agentic workflow may comprise many different types of components, and so your tools for improving different components will be pretty different. But I'd like to share with you some general patterns I've seen. Some components in your agentic workflow will be non-OM based. So it may be something like a web search engine or a text retrieval component if that's part of your RAG or retrieval augmented generation system, something for code execution, or maybe a separately trained machine learning model, maybe for speech recognition or detecting people and pictures and so on. So sometimes these non-OM based components will have parameters or hyperparameters that you can tune. So for web search, you can tune things like the number of results or maybe the date range that you ask the web search engine to consider. For a RAG text retrieval component, you might change the similarity threshold that determines what pieces of text it considers similar or the chunk size. Often RAG systems will take text and chop it up into smaller chunks for matching. So there are many hyperparameters you could use. Or for people detection, you might change the detection threshold. So how sensitive it is and how likely it is to declare this found a person. And this would trade off the false positives and false negatives. If you didn't follow all the details of the hyperparameters I just discussed, don't worry about it. The details aren't that important, but often the components were parameters that you can tune. And then of course, you can also try to replace the component. I do this a lot in my agentic workflows where I'll swap in different RAG search engines or swap in different RAG providers and so on, just to see if some other provider might work better. Because of the diversity of non-OM based components, I think the techniques for how to improve it will be more diverse and dependent on exactly what that component is doing. For an OM-based component, here are some options you might consider. One would be to try to improve your prompts. So maybe try to add more explicit instructions. Or if you know what few-shot prompting is, that refers to adding one or more concrete examples of an example of an input and a desired output. And so few-shot prompting, which you can learn about from some Deep Learning AI short courses as well, is a technique that can give your LM some examples to hopefully help it get better performing outputs written. Or you can also try a different OM. So with AI Suite or other tools, it could be pretty easy to try multiple OMs, and then you can use evals to pick the best model for your application. Sometimes, if a single step is too complex for one LM to do, you can consider if you want to decompose the task into smaller steps, or maybe decompose it into a generation step and then a reflection step. But more generally, if you have instructions that are very complex all within one step, maybe a single LM has a hard time following all those instructions, and you can break the task down to smaller steps. That may be easier for, say, 2 or 3 calls to an LM to carry out accurately. And lastly, something to try when the other methods aren't working well enough is to consider fine-tuning a model. This tends to be quite a bit more complex than the other options, so it can be quite a bit more expensive as well in terms of developer time to implement. But if you have some data that you can use to fine-tune an LLM on, that could give you much better performance than prompting alone. So I tend not to fine-tune a model until I've really exhausted the other options, because fine-tuning tends to be quite complex. But for applications where after trying everything else, if I'm still at, say 90% performance or 95% performance, and I really need to eke out those last few percentage points of improvement, then sometimes fine-tuning my own custom model is a great technique to use. I tend to do this only on the more mature applications because of how costly it is. It turns out that when you're trying to choose an LM to use, one thing that's very helpful for you as a developer is if you have good intuitions about how intelligent or how capable different large language models are. One thing you can do is just try a lot of models and see what works best. But I find that as I work with different models, I start to hone intuitions about which models work best for what types of tasks. And when you hone those intuitions, you can be more efficient as well in writing good prompts for the model, as well as choosing good models for your task. So I'd like to share with you some thoughts on how to hone your intuition on what models will work well for your application. Let's illustrate this with an example of using an LLM to follow instructions to remove or to redact PII, or personally identifiable information. So get an LLM to remove private sensitive information. For example, if you are using an LLM to summarize customer calls, then maybe one summary is, on July 14th, 2023, Jessica Alvarez with a social security number at a certain address, submitted a support ticket, and so on. So this piece of text has a lot of sensitive, personally identifiable information. Now, let's say we want to remove all PII from such summaries because we want to use the data for downstream statistical analysis of what customers are calling about. And to protect customer information, we want to strip out that PII before we do that downstream statistical analysis. So you might prompt an OM with instructions to identify all cases of PII in the text below, and then return the redacted text with redacted, and so on. It turns out that the larger frontier models tend to be much better at following instructions, whereas the smaller models tend to be pretty good at answering simple factual questions, but are just not as good at following instructions. If you run this prompt on a smaller model, the open weight llama 3.1 model with 8 billion parameters, then it may generate an output like this. It says the identified PII is social security number and address, and then it redacts it as follows, and so on. And it actually makes a few errors. It didn't follow the instructions properly. It showed the list, then redacted the text, then return another list, which it wasn't supposed to. And in this list of PII, it missed the name. And then I think it also didn't redact part of the address. So details aren't important, but didn't follow these instructions perfectly, and maybe it missed a little bit of PII. In contrast, if you use a more intelligent model, one that's better at following instructions, you may get a better result like this, where it's actually correctly listed all the PII and correctly redacted all of the PII. And so I find that as different OM providers specialize on different tasks, different models really are better for different tasks. Some are better at coding, some are better at following instructions, some are better at certain niche types of facts. And if you can hone your intuition for what models are more or less intelligent and what types of instructions they're more or less able to follow, then you'll be able to make better decisions as to what models to use. So to share a couple tips on how to do this, I encourage you to play with different models often. So whenever there's a new model release, I'll often go try it out and try out different queries on it, both closed weight proprietary models as well as open weight models. And I find that sometimes having a personal set of evals might also be helpful, where there's a set of things you ask a lot of different models that might help you calibrate how well they do on different types of tasks. One of the things that I do a lot that I hope will be useful to you is I spend a lot of time reading other people's prompts. So sometimes people will publish their prompts on the internet, and I'll often go and read them to understand what best practices in prompting looks like, or often chat to my friends at various companies, including some of the frontier model companies, and kind of share my prompts with them, take a look at how they prompt. And sometimes I'll also go to open source packages written by people I really respect, and download the open source package and dig through that open source package to find the prompts the authors have written in order to read it, in order to hold my intuition about how to write good prompts. This is one technique that I encourage you to consider, is by reading lots of other people's prompts that will help you get better at writing prompts yourself. And I certainly do this a lot, and I encourage you to do so too. And this will hone your intuition about what types of instructions models are good at following and when to say certain things to different models. In addition to playing with models and reading other people's prompts, if you try out lots of different models in your agentic workflows, that also lets you hone your intuition. So you see which models work best for which types of tasks, and either looking at traces to get an informal sense, or looking at either component-wise or end-to-end evals can help you assess how well different models are working for different parts of your workflow. And then you start to hone intuitions about not just performance, but maybe also price and speed trade-offs for the use of different models. And one of the reasons I tend to develop my agentic workflows of AI Suite is because it then makes it easy to quickly swap out and try out different models. And this makes me more efficient in terms of trying out and assessing which models work best for my workflow. So we've talked a lot about how to improve the performance of different components to hopefully improve the overall performance of your end-to-end system. In addition to improving the quality of the output, one other thing you might want to do in your workflows is to optimize the latency as well as cost. I find that for a lot of teams, when you start developing, usually the number one thing to worry about is just, are the outputs sufficiently high quality? But then when the system is working well and you put it into production, then there's often value to make it run faster as well as run at lower cost as well. So in the next video, let's take a look at some ideas for improving cost and latency for agentic workflows.